Hey there, my name is Jeff Johnson, Chief Design Officer here at Nested Knowledge, and I'm joined today by Kevin Kalmus, CEO and founder of Nested Knowledge. Kevin, what are you thinking today?
Thanks, Jeff. And I actually thought that it was past time to create a video where we took our software from beginning to end and built a full AI review in one session. As you
Excellent.
know, some of the most talented researchers out there using nested knowledge have developed these methods. They're well published on, but I think that would help to show people how to do not just a systematic review, but a fully human in the loop
Mhm.
targeted review in the software. Yeah.
Let's give people an overview of what nested knowledge is first, and then maybe I can bring you sort of a naive research question, and then our system can refine that research question, and we can do that review.
Amazing. All right, yeah. Let's start from an overview, and then let's jump to your research question. So you get ready. You think about,
Mhm.
what is your key medical related research question?
Okay.
What are your populations of interest? What are your interventions and outcomes? And while you do that, I will just talk through our system. When you come into Nested Knowledge, as long as you have a research question that can be turned from basically your populations, interventions, comparators, outcomes, or other medical questions, epidemiology, cost effectiveness, as long as it can be formulated into a research question, we can turn that into a search strategy. So come in with a research question, and in the first stage in Nested Knowledge, we will help you create an AI assisted Boolean search, which you can run across databases. This will kick off what we call our autolit process, which is the AI assisted mechanism to go through every best practice in a systematic review. So once we search with fully replicable and transparent search strings, we can screen. The
Mhm.
AI will either serve as a second screener, sort of in a hybrid mode, which is what people normally use for the systematic reviews,
Mhm.
or you can use fully LLM screening, which I will do today. Obviously, everything that I show today will be fully human in the loop, but the question is always for a TLR, how much curation should you choose to do compared to a fully curated systematic review?
Right.
Then I actually want to double down on discussing tagging today. Tagging is our replacement for the Excel sheet. This is how we extract data from underlying studies, and we have multiple mechanisms to do so, including qualitative, quantitative. But really, what tagging represents is your opportunity to tell the AI what to extract, and then be given automatic outputs. So if you
Mhm.
do search and screen and tag, and even if you go on and use our meta analytical module, the system will build out your synthesis page, which is a link shareable, QR code shareable dashboard where you can see your qualitative findings, your quantitative findings, written findings, and even have the AI write up your insights. So if you zoom out and take the whole picture, Nested Knowledge is taking you through the entire review process from your research question, searching, screening, extracting data, giving you your outputs, and then the whole thing is living. So if you wanted to, you could always refresh that search and get a new review out at any later date.
Amazing. Autolit plus synthesis. Should we dive in?
Please let me actually go to our
Yeah.
application here.
Okay, so in terms of research questions, one of the interesting things that I've noticed come up recently. So GLP-1s, kind of a hot topic, right? I guess my population would be anyone who's been treated with a GLP-1, perhaps for diabetes, probably more for obesity. Seems to be kind of a increasing use case for this thing.
Great.
And then let's do this for the outcome or the maybe the safety outcome that I'm interested in would be like muscle mass loss, right? Like, okay, you're going to try to use this for obesity treatment, but what happens to your muscle mass? What happens to kind of other systems in the body that you might care more about and might not want to lose, perhaps? And let's just explore that research question.
No,
See what
I love it. I think this is not just a question for the research community. I think this is actually a pressing
yeah,
question for our society as we jump in and use these for improving health outcomes. But of course, we want to ask at what cost.
yeah,
So all I've done so far, I went to our homepage. You can always click on the blue nests in the upper right hand corner. That will
yeah.
be where you can see all of your past reviews and also create new ones. We hit create new review, and then we created one on muscle mass loss. You can always draft a protocol before you jump in on a
Hmm.
review. For this, we're going to speed ahead and go
Hmm.
straight to our search page, which is the first page that you'll be dropped on when you create a project. And we are going to go straight into Smart Search. And I'm going to take your research question as I heard it. So basically
Yeah,
GLP-1 receptor agonists or really we want to say treatment
yeah,
safety in terms of muscle mass loss. And I'm
yeah. Yeah,
Certainly phrasing it sort of naively in the same way that you did, we're going to
yeah,
have the AI help refine that into something that actually captures those PICOs. So
let's do it.
specific patient populations, you'd say any.
Yeah, yeah,
And then for the other questions, any GLP-1, right? So no
yeah,
limitations there.
yeah. They're all sort of interventions slash comparators. But I'll be interested to see um, how each one performs, I suppose.
And I'm going to just say muscle mass loss and sarcopenia as
Sure.
my main outcomes that, well, yeah, hopefully that reflects what you're looking for.
Yeah.
You can also put in things like study types. You can put in other restrictors, but really you should answer the AI's questions or give more information until it becomes well refined. And we
Mhm.
can hit save and generate. And so just in
Awesome.
that first, I don't know, 30 seconds, we've gone from research question to refined research question, and now we're going to turn that into a Boolean string, which you can run across databases. I do want to call out that if you were going to run a search externally and bring that in, as people will often do for systematic reviews, you should, instead of clicking Smart Search, click
Yeah.
Add. And then you can either add your query and run it across the databases that we offer. So PubMed is the most commonly used. OpenAlex plugs into Semantic Scholar. A lot of people
Mhm.
do trial registry searches on clinicaltrials.gov through us. And you can not only run those searches, but you can make them living. So if you wanted to do a daily update, a weekly update, or anything like that, you can do
Mhm.
that directly in the system. And if you have an Embase search or a Cochrane search or anything else you want to add, you can, of course, use our file import. We will take care of all deduplication in the background and set you up with your screening of your manually drafted searches, of your imported records, and also of the AI drafted searches here.
And you can also add other sources, obviously, just as
Of
expert
course.
recommendations, all of which will be sort of presented to you nicely in synthesis via the Prisma diagram, right? So that's another piece that we'll talk about at some point. Yeah.
Oh, of course. I actually think why not up front?
Yeah.
Traceability is so important to us.
Yeah.
Everything that you do in the system, we will track to ensure that you are able to give your search strings and your full traceable screening decisions
Mhm.
in a Prisma diagram in your outputs, including expert recommendations or even BiblioMind records. We do have an AI
Mhm.
that will extract records from underlying existing systematic reviews and give you a starting point
Mhm.
for all of those things. I should note that if you are doing a systematic review, I actually consider it a best practice to go to some existing systematic reviews and pull their records.
Sure. Sure.
Let's stick with the TLR track here.
Yeah. Yeah.
Um, yeah. So the other difference between TLRs and systematic reviews, not only would you probably want some help, so invite your
Mhm.
organization, invite your friends to review with you if you're doing a systematic review. But the main difference will be how much are you quality controlling the AI's findings here.
Mhm.
So if I was doing a systematic review, I would probably do abstracts and full text as separate stages. I would probably do dual adjudicated review. And I would probably do manual decisions to feed the AI.
Mhm.
Since we're doing a TLR, I'm going to use our dedicated criteria-based screening, where
Mhm.
instead of my screening, training the AI, I'm going to simply prompt the AI and it will run without any training needed.
Yeah.
So a major decision for systematic reviewers versus rapid TLR reviewers is going to be the mode and the AI that you choose to use.
Yeah.
Okay, so with that, all that set up out of the way, I'm sure that the AI is done building our search strategy. In fact, it's done building our search strategies. Here
Mhm.
we can see that we have a more systematic, recall-focused approach, so trying to miss as little as possible. We have a hybrid search, and then we have a TLR search, where it's just going to give us the terms that are going to get us the studies that are as focused on our research question as possible. Here we can see the AI is basically cottoned onto the fact that you don't have a population restriction, and it's
Right.
just drafted a search that is focused on
Let's
GLP-1s.
let's roll with that. Sounds great.
Perfect. And then some outcomes of interest. We could, of course, add any further hedges we want here. For instance, if I wanted to, I could, come in and add like not, and then mice or animal searches or something
Sure.
like that.
Sure.
Maybe I can leave that off for now and let any user make their own search. I'm going to run with the AI search, and maybe let's go back, say 5 years on this one.
Sure. Sure.
All right. So safety evidence in the past 5 years on sarcopenia muscle mass loss for GLP-1s, and I'm going to hit add. Okay. We are done not only with Nest setup, but we have run our first search. While that is running, I think we can run forward and configure our screening reasons. But I
Mhm.
should call out that this, like the other tools shown here, is fully validated. We actually did a comparison of human versus AI by taking Cochrane reviews, feeding the first sentence to Smart Search and then seeing if it could replicate them. And it was able to find 80% of the records that Cochrane reviewers reported. So certainly far better than what you do with the foundational model, but more at the level of a junior researcher that you might want to refine. So we certainly want to highlight the human in the loop on that portion. But why don't we just move forward and start configuring screening?
Right. We can start with kind of intervention-based criteria, perhaps.
So for this, we need to frame it, and we have a very, very simple prompting guide that we'll give alongside this.
Yeah.
But really, we want to ask a question that has a yes answer and is as clear as possible. So, did the study report a GLP-1 receptor agonist? If I want to be very specific, treatment of patients with a GLP-1 receptor agonist. If I wanted to, I could give examples as well. So we do recommend handle edge cases, give examples. So
and to some extent, those are sort of captured by GLP-1, and a large language model might understand that in a broad enough topic like this. But yeah,
I'm certainly doing overkill by giving those examples, but I think
it's good practice.
It's good practice. So better to instruct a little bit too much than a little bit less. For study type, I'm assuming any clinical study.
Yep.
Must be observational. And you can see the last one I did a question. I'm going to give a command here. Study must be observational or experimental.
Right.
In human patients.
There's probably a lot of animal studies here that we want to get.
Exactly. Yeah, we got to kick out the mice studies, such as prospective cohort. And I can keep listing as many as I want. I can also then say exclude, let's say exclude editorials, letters, and case reports. So handle edge cases, give exclusions alongside the inclusions, give examples, hit save, and we now have a prompt on study type. And then your last one here, we're going to do outcomes, and you want to basically safety outcomes related to muscle
mass loss. Yeah. Sarcopenia.
And then this is also validated, I should say. There was a great group that actually has been pioneering rapid review in the technology that published at ISPOR a validation of at each stage here, and they found over 85% time savings and over 90% accuracy for screening and all extraction, and even for critical appraisal. But they did use the criteria-based mode here. You do need to be careful in your configuration because you only want to ask, for instance, at the abstract stage for things that are reported in abstracts.
Right.
All right, and we can just hit save, and let's leave those there. We should be more deliberate in a true TLR about anything that would be sort of a line in the sand, but I'm going to go ahead and run the smart screener here on abstracts, and I'm just going to hit generate. This will not fully screen the underlying records. Instead, it will assess every criterion, and then we can check them in the underlying studies. In fact, if I wanted to, I could manually screen right now with the criteria that I've configured. So we can see that this is a study of rats. So if I wanted to, I could just simply click in and say the study type is incorrect. I could annotate it if I wanted to, but I think I can just kick this one out and say for study type, this one is excluded and move forward.
Nice.
So I can screen this one. Again, I can annotate anything that I want here. If I wanted to say that the intervention is correctly given here. I should do that for intervention, not for study type. I can manually curate all of these and then make decisions. But I can, of course, also, in this case, I'm going to trust the AI is going to be able to take care of screening for us. So manual screening is perfectly fine within the system. But for targeted reviews, we will often run the AI and especially depend on it for excluding the right records.
Right. And, this is also a useful interface for reviewing what the AI has done once the system has completed its task of automatically running for these questions.
When we come back around and show the completed AI run, it'll actually do that highlighting for us, assess each of these as yes or no, and allow us to either make a decision here or to use the thresholding where we can say, hey, go ahead and include if it satisfies all three criteria. We could also do something like say exclude if it's below, but I'm going to review the includes. Basically, I get the choice about how much to curate these underlying records.
Yeah, and that's a hallmark of nested knowledge. You'll see that throughout. AI might be a black box at times, or it might feel like that, but nested knowledge is going to peel back the layers, peel back the curtain, so that you can kind of see what's under the hood.
And that you control what's under the hood.
Yeah,
We
yeah,
are very much trying to put you in the driver's seat for search, for screening, and now even for
yeah.
extraction, which we can already begin configuring. I should note there are three main strategies for tagging, and if we zoom out again, we said tag is our qualitative and quantitative extraction at the opening. This is also where I think most people need the greatest sort of introduction and training, because this is our most
Yeah.
inventive new feature. Tagging is a replacement for an Excel sheet. It is also a way to filter to concepts of interest. So if I wanted to say I'm really interested in muscle mass loss related outcomes, I can start configuring tags, and these will turn into prompts to the AI. But it's also going to be our very specific extraction, where similarly to in the screening phase, we're going to prompt the AI, and we're going to say, I want to know, let's say in this case, let's
Hmm.
summarize muscle mass loss. And then I'm going to make that an apply tag. Very simply, an apply tag would be give me the answer based on an extraction from the underlying study.
Hmm.
A select question would be give answers below this. So a good example would be study type. If we wanted to add a study type hierarchy, we would probably put a select question at the top and then say pick the study type and give
Yeah.
options like randomized trial, prospective cohort, and so on. The question here is our prompt. So if we're prompting here on summarize muscle mass loss, we can simply ask the AI to summarize all safety related reporting of muscle mass loss related to GLP-1 treatment.
And this process can be somewhat painstaking. We have some tools for that as well, right, Kevin? So the first one being like templates, right?
That is my favorite one, in fact, and that's exactly where I want to go. Rather than prompting in full, and of course, I'm going to come back and show you what I would give as a full prompt
Right.
here. I can also just go to our organizational templates. If you don't have these at your organizational level, use our public ones, but I actually have a safety template that I've already created. So I can grab that and hit import. And you can see that the system has already built out a lot
Hmm.
of these prompts for me. So if I wanted to click in and say, like, show me the subgroups reported, we can see that past Kevin has already helped me out by prompting the AI. And a lot of these, you can test the AI on the questions that you put into the template, and then you're going to have better
Yeah.
performance by the AI. Because in our prompt guide, on top of saying things like make sure to give clear guidance on what should be extracted, our number one piece of advice is test and retest your prompts to make sure that you're communicating well with the AI.
Hmm.
Much like these tags that I've created below, for this top level tag I'm creating here, I should think about three things. First is going to be the simple statement of the literal information I want reported. So summarize safety outcomes for GLP-1 treated patients. I should also think about edge cases or examples. In this case, I think we're probably okay. We already gave an example of sarcopenia. And then the last thing we should think about is the format. So the format here, we want to say report let's say bullet points, right? If I wanted that, I could also say full sentences. I could also say individual words, and I'm going to say be concise. So if I want to give instructions to the AI on how it's reporting, I can do that textually. I can also build out more extensive prompts. Like if I wanted,
Yeah.
instead of a summary of muscle mass loss, I could say make a tag for sarcopenia
Right.
quantitative, and say across treatments, extract the muscle mass loss
Hmm.
and sarcopenia for each patient population. Give numerical data. And I could be more
Yeah.
definitive and say only numerical data, but if I want to
Hmm.
give the AI some flexibility, I
Yeah.
can do so. And if I want it to be quantitative, then I should actually jump in and give some columns to the AI. You can actually instruct the AI on building out a specific table of what you want. So let's just build out and say, give me a table where the first column would be our treatment. And then we can even say, list the drug therapy given to the. We can say the number of patients. And then I'm going to say sarcopenia, mean muscle mass loss. And of course, I could put this down in the instructions too. So if I wanted to, I could put all this text down in the column instructions. And then I'm going to also ask for time point.
Sure.
So I can build a miniature Excel sheet into my question. I should make this a quick apply tag. And then we can ask either a qualitative question or a quantitative question of the AI and run those to bring back answers. So we've really just shown two ways to create individual tags, so text tags and then quantitative extraction. But if we zoom out, we also have this template where we can pull information that we've already structured. We can pull population, the interventions used, the outcomes. You can see I've already structured one for weight loss and muscle mass loss. And then also, if we wanted to, we could generate further tags that assist us. If you want the AI to generate your PICOS, you can do so here. I'm going to deselect that, and I'm just going to have the AI extract our study type, size, and location. This is all automatic, and I can just hit apply. Core smart tags are fully built by the AI with no extra work needed by you. It will build out your study size. Wow, that was quick. Your study size, type, and location hierarchies for you and extract them. And you can tell these are AI configured because they have the little AI sparkle on them. And I might even delete my extraneous manually configured study types in that case.
Nice.
All right. Let's go ahead and run the AI. We have configured some manual tags. We've used a template, and now we've even used the AI configured tags, but we can also jump in and run our adaptive smart tags. This is our main tool for extraction. And what we can do for that is both the abstracts, and then once we upload full text, we can also run on full text, and it will go into the underlying text. It will extract the information of note. If you have a PDF, it will actually read tables as well as text, though figures are for manual extraction. And you can, of course, pick things like, I want this on only included records, or I want all annotations required, and so on. So I've gone ahead and run that. I think we can let that run, but I don't think we actually came back around.
Let's check on our screening.
Exactly. So we ran the AI and it gave us answers, and then we went forward into all of our configurations so we can let the AI run in the background. For screening, you can see that the AI is brought back out of just under 600 studies. 401 report GLP-1s, 186 are clinical, observational, or experimental studies, and then the sort of crossover between these is going to be where we threshold. So of these, the studies that report our intervention and our study type and our outcome, let's go ahead and use sort of the highest threshold. We're going to say must report all three and hit apply. With that, we have now done fully AI screening of almost all of our records. I should note that the system will leave those that don't have abstracts for us to manually screen because it doesn't have enough information for an AI decision. You can either go and source the full text or screen this yourself. But 576 out of 596 had abstracts and have been successfully screened by the AI. And if we want to see what that looks like, I'm going to click in on one of these studies. This study reported the treatment of patients with liraglutide is an observational study and reports decrease in absolute lean body mass. So it satisfies all three criteria and it can come in. I can see that we also have a PMC eligible full text. So for any of our included studies, I'm actually going to go ahead and do a very important stage in nested knowledge, which is full text import. I'm going to say document import. This is a bulk action. I've first filtered to our included records. I'm going to do a bulk action, import, and then import from on paywall. You can also bulk upload from your own device for any subscription articles, and that will give you the ability to bring those in and run the adaptive smart tags on all open access and non-open access tags.
Right.
We can also see that the AI has included 87 total records out of 500. And so these are going to be our fodder for both AI and full text extraction. And we've already sort of cleared two of the major hurdles in a review. We've searched and gotten back our records of interest, and then we've screened and gotten to our set of includes. So we're already on the home stretch in the review. The last thing that we really need to do is run the AI on first abstracts, which we've just done, and then turn around and run those same questions on full text, and we will actually get full extraction from those underlying records. So in terms of setup, I think we've already run very quickly through research question, screening criteria, and now how to configure tags. I will say that when it comes to your strategies, the screening criteria are going to be the easiest to adjust. You can always go back, change them, rerun the AI, and sort of treat it as a refinement process. Tagging is where I would recommend focusing your effort on learning the system, but also on refining how you're framing it, not just so the AI understands you, but so you get your outputs in the format that you
Mhm.
like. So I see here intensive questions that satisfy those 3 rules that I gave. State what you're looking for literally and clearly, manage edge cases and give examples, and tell the AI the format of any outputs. And you can do that across not just your tag names, but you can even do that for columns within your tag tables.
And just like in screening, we're going to have an interface where you can review any AI decisions that have been made with full data provenance back to the full text or to the abstract, wherever that information was found, or just to manually run through and answer these questions yourself.
100%. And even for these questions, you can actually see, like, if I wanted to say, show me all say study types reported,
Mhm.
I can click in and the AI will immediately show me where it's finished extracting. So I click on the tag, I click examine, and it will trace me in the underlying abstract or full text to the spot where it extracted that information. And treat this basically as a quick insight into what each underlying study reports, even just from the configuration page. For the actual extraction, we recommend jumping over to the human in the loop workflow, where you're going to get the full text, you're going to get the tags, and you can go through and answer these manually. Once the AI is finished running, it'll also auto-populate those answers, and you can see them here.
Yeah.
While the AI is running, I think we've covered how to configure tags, again, manually with core smart tags or with templates. We've covered how to review them, and we'll come back around and show
Yeah.
this when we have AI answers. Why don't we jump forward and show how to create some of the Nest outputs?
The outputs, yes. The end game here is
Awesome.
we want to replace Excel.
You want answers to your
Right.
questions?
We want to replace Excel, but we also want to give you the ability to download tables to Excel, because oftentimes that's what you're expecting at the end of a review. It's just a spreadsheet of all your data. So of course we have a solution for that as well.
100%. And this is better than Excel in multiple ways. The first of it is that it is living. So as you update your searches or your screening or extraction, even I'm going to build this table before the AI is done running, and it will autofill this table with the answers to our key questions, like summarizing muscle mass loss or extracting sarcopenia. If I want to, I can basically build out these tables as my future outputs, and I can even create let's say a Nest template that would be all of the criteria, the tags, the dashboards, sort of drained of their specific content to our disease state, but it's all set for me to turn into my Excel outputs and my shareable dashboards. The second way that I think this is better than an Excel sheet is that it is interactive within the system. So once I've added these tags, let's say I wanted to also get my sarcopenia quantitative tag here. And maybe let's also add an intervention tag. We have a lot of flexibility there, where if we wanted to extract the exact intervention, we can say, give me the exact name of the intervention at or below GLP-1, let's say, and we can add those columns, hit add. And this is interactive such that even before the AI is done running, I can click in and see the underlying screening and tags for everything that's been brought in. Oh, and it looks like the AI finished while I was talking, and we can already see that it's summarizing our muscle mass loss, and it's extracted quantitative sarcopenia evidence directly into this view. And if I simply refresh this page, it will actually show it for our whole dashboard.
Yeah.
So we can already see that the summary of muscle mass loss, the safety outcomes outside of muscle mass loss, and sarcopenia are already qualitatively and quantitatively extracted and displayed.
And remember, this is a living review, right? So we're not just waiting for that AI, job to run. We're also waiting for the search to repeat and for new records to become available and new rows to be added to this table. So from start to finish, you truly can expect a living review in Nested Knowledge.
That's exactly right. Everything is built as if we expect you to be asking important questions that need continued answers. And I actually have multiple weekly reviews that give me updates on key topics that I care about or the people that I'm working with. And once you refine it down and you have your templates and you have your dashboards already built, it really is a matter of minutes to get in the incremental evidence and show new findings.
Okay, so we can get tables. We can also get a couple other interesting dashboard, kind of cards, different ways to visualize your data, right?
100%. I'm going to add my 3 favorite. So the first is that traceability that we already talked about before. We have your full Prisma diagram. We showed you why every record was excluded. We show you the flow from your search all the way through to your included records. The second one, study location often matters, and we actually have a dedicated study location tag with a map. And can add that, and you get a map of where studies were reported. And then my last one that I'm a huge fan of, and I think Nested Knowledge has become associated with sunburst diagrams, you can actually create your own miniature sunburst diagrams. Let's say we wanted to do that for study type and do a breakdown here. And you can do this for any tag. So if you wanted to do interventions or key outcomes, and then just select sunburst, and we're going to add that in, and we're going to get a diagram that will tell us, are we getting evidence from randomized trials, secondary analyses, observational studies, reviews, and so on. So very quick drill down on the underlying contents via Nested Knowledge knows that we will also build interactive sunbursts automatically for you to see in the synthesis page. I am going to quickly add another table just to show we have our high-level muscle mass related outcomes, but let's also do study details, do our homework on what sort of studies are we actually bringing in here. And note that if we wanted to, we could add bibliographic data, links, full citations, anything that you need to support the review, as well as tags. I'm going to focus on the contents. That's what's interesting to me, but you have a lot of flexibility in what's brought in here.
Right.
So if I wanted to, I could just show, for instance, what is the size of the study, what is the location of the study. I can show what are the key safety outcomes reported. I could even do that at the highest level and just ask what outcomes are reported in general, click in, and maybe even do that for efficacy outcomes separately from safety outcomes. And then it'll just give me an overview of the reporting, not of every single outcome within that, but it'll at least tell me what I should be looking for in every underlying study. We have that flexibility in how these tables are configured. And if you want to, you can even do things. We think a lot about the user interface, and you more than any. And so you can absolutely get yourself to a nicely wrapped table for download.
Right.
Okay. The synthesis that I was referring to, we have, in addition to our Prisma diagram, which I've already shown, you can see the search history there as well. In addition to the dashboard, which you've just seen me build out, we also have interactive qualitative synthesis, where we've automatically built your hierarchy, and you can do simple filtering, where if we wanted to, say, zoom in on what GLP-1s are reported, and then filter, we could say, show me all studies that report semaglutide, and click in on any underlying study, and it will show me traceable extraction of each of those underlying concepts, including, of course, why we know that this extracted semaglutide, but also each of the outcomes from abstracts or from full texts. So traceable, interactive, and filterable. This is also where you can link share. So any page on the synthesis side of things is link shareable, QR code shareable. I know you're a fan, Jeff. If you keep this private, you can actually put full text there so that those who share your subscriptions can see them. But if you are sharing this publicly and using those links, we will automatically hide that. So you're only showing the systematic review outputs and not accidentally leaking data on anybody.
Correct.
Okay, so I think let me do a brief overview of what we've done so far. And I have kept one thing in reserve, and that is I want to also show you our newest AI tool for giving you written insights based on those underlying tags. So the last thing that tagging does that an Excel sheet doesn't is it does feed into AI summarization. So we will get to that in approximately half of the time that it has been running. But let's go from the start again and just do a quick overview of how we got here.
Sure.
Yeah, so we started from a research question. We just used the smart search. We jumped in on the TLR version, or the most narrow version of that search. We ran it on only PubMed. We kept it as the AI built it, but we could, of course, edit it as much as we want before we run it on multiple databases, bring in other sources, bibliomine, anything we'd like to do. We then screened those studies, and this uses our criteria-based or smart screener. If you're ever wondering, like, how can I know where the AI tools in Nested Knowledge are, you'll see that both on the search page, screening page for configuration, the gear icon for tagging, all of those AIs are these white buttons in the upper left-hand corner. What am I saying? And you can just click in and see exactly how they work. For the Smart Screener, we do fully automated abstract screening, fully automated full text screening. You can require the AI to give you annotations for traceability, and then you can manually screen as much as you want, jump in, assign reasons to studies, and include or exclude. You can also, of course, review and override any of the AI decisions. I've seen many strategies there, from review all includes to review all studies that meet at least 2 criteria, or whatever line you might draw in the sand. For tagging, we focused heavily on the sort of more manually configured and templated approaches, where you can give a name, give a prompt, and give a question type for both text and for tables. So if you want qualitative extraction or quantitative extraction, we really have very simple configurations, especially if you're going to reuse these. And we recommend building every tag as if it's going to become a prompt template, or even really think about this as a prompt library for your future extraction. And that gets us through to our set of included records and our extraction from them. When we run these AIs, Core will build hierarchies itself. You can see we built out our study size, location, and study type tags. But Adaptive will extract from abstracts, from full text, and can have that same choice about whether you require the AI to trace its answers. And then you can review those, where you get basically the human in the loop. Full text or abstract on the left, your answers on the right, and this is going to trace to where it found the information of note for any of your extractions. And you can see here, the AI has actually been quite successful. It's either answered or determined each of these questions to be fully not relevant. So fully AI screening with human curation. If I wanted to change any of these extractions, I can click in on any text in the abstract or the full text, highlight it, and have that as my extraction, or I can overwrite what the AI has added here and hit update. Okay, Jeff, what questions do you think I've missed out for users?
Well, I think the problem is, we've done an entire review in just over 30 minutes, and that's a lot of information, and there's still more to be covered. We can't actually cover all the features. There's meta-analysis in nested knowledge. There's critical appraisal in nested knowledge. Yeah, plenty of other features that we can talk about. But you'll just have to reach out to us and contact us, and we would love to hear from you. If you want another demo that's specific to your research question, it could be, as you can see, naive or rather well formulated. You can bring us a whole protocol. You can bring us a half-completed systematic review that you're working on, that you need to dust off and complete a little bit more quickly than is currently possible with your current workflow. Bring us those types of questions. We help people like you all the time, and you too can become an expert in nested knowledge and can do 30-minute reviews as well, just like Kevin did. We've made that process, I hope through this video, somewhat transparent, right?
Absolutely. And actually, in terms of transparency, we have published methods. We have a methods paper that goes through every one of the AIs. We have a rapid review guide that has a 3-minute video on smart search, on criteria-based screening, on tagging. So you don't need to go beginning to end on any of these. You can jump in and use our rapid review online guide. We'll link that here. I wanted to make one last shout out before we check out our insights, and that is to the Study Inspector page. This is our non-AI page. This is for those who are, if you're a data analyst, or if you've used SQL ever, this is a very good way to drill down on underlying studies. You saw us use it when we were uploading full text, but this is also a very good place to take bulk actions, to quality control, even to download evidence based on filtering. So if I wanted to say filter to those studies that report semaglutide and any muscle mass loss, I can filter and I get those studies. I can then download them as an Excel sheet. I can get their bibliographic data. I can also click in and curate those and make sure that the AI is correct about what it's extracting around sarcopenia or muscle loss summary. And I can do things like bulk include, bulk exclude, bulk apply tags, bulk remove tags. I can even do Boolean filtering, where if I wanted it to be, instead of semaglutide, if I wanted it to be semaglutide or tirzepatide, I can jump in and filter that way. So, and this is no code, right? If you're SQL competent, this will seem extremely rapid and easy. And if you haven't used a database language before, this is your entry into data science. I think you can do a lot more work using AI plus, really good filtering in data science than you can do with AI alone.
I would agree with that. Yep.
We also actually say, if your favorite feature in nested knowledge is Study Inspector, you probably do a lot of reviews. So those who are coming back again and again, make sure that Study Inspector is a focus for you.
Yeah.
I think our insights are probably ready. Let me go in and check in on that. All I've done so far is I hit generate. all insights are based on the tags you created. So if I wanted to add an insight, say for quantitative sarcopenia outputs, if I wanted to add an insight for our muscle mass loss summary that we created, I can add those. I can also click add all if I wanted to add all 20 of these insights, but let's pull out a couple more important ones. Maybe let's do like an overall safety outcome summary. And these don't have to be results focused. I could also do things like summarize the populations reported, subgroups reported, inclusion, study types. Anything that I tag can be turned into an insight. So what you really need to think about if you like the insights feature is going to be, did I create a tag that would get me the information of note here? So let's say I wanted to get the disease treated as well. So what do those look like in the system? Each one of these is going to give you a textual written result where every single statement within that result is going to be traceable to the underlying studies that report exact text segments or exact quantitative evidence supporting the insights. So this is the opposite of black box approaches. This is fully traceable AI interpretation. We're not just feeding it the full text. We're not just having you chat with the papers like you would in GPT. We are taking your exact extractions that are based on your prompts and your tags and your quality control, and we are summarizing it with full traceability. These are also downloadable into Word, but you can probably tell that it's really helpful to have interaction within the system where you could click in and say, show me, the semaglutide groups, show me the sarcopenia summary, show me the muscle mass summary, show me any of the outcomes that have been extracted here directly within the system. So you can get traceability on the fly for each of those insights. So on top of sort of tabular outputs, on top of interactive visuals, on top of really just like living review in general, you can have living AI insights. And if we jump out to the dashboard here, you can see that any external user that you link share this with would be able to jump in and see not just those, again, like let's say higher level like deep dives on the data. You're going to also get the 5-sentence summary based on any qualitative or quantitative data in the underlying study. So in effect, and I know this has been something that's been asked for so many years in Nested Knowledge, we have finally cracked AI writing that we think we can trust. Not because we think we are better than foundational models at interpreting what you're looking for, but because we've put appropriate guardrails to make sure it's only summarizing the extracted data under your tags with traceability. So hopefully that's a way to get you from your initial research question, right? Jeff, you came in wanting to know about muscle mass and sarcopenia and GLP-1 therapies across all diseases treated. We've given you that in terms of tables of data. We've given that to you with traceable methods. We've given that to you with tags that you can get at the study level, but we've also given you insights that summarize and bring together the conclusions from this review. And with that, I'd say we have completed a 1-session rapid review in the tool. So yeah, with that, any final thoughts for our users or potential users?
No, that's an excellent summary, I think, Kevin, and informative as always. Thank you. We'll get this up on the site, and we'll link to a couple of things that we talked about in this session. Mostly those validation studies. We always do our own internal and external validations that our users our excellent users have done themselves
on our behalf
and published. Yes, at various conferences and in journals. And then we'll also link to our documentation so that you can do a deep dive into this. But if you have questions, feel free to reach out. We'd love to hear from you.
I was going to say, there's nothing that Nested Knowledge team members like more than hearing an interesting research question we can help you start off with. And as you can probably see from today, we will simply jump on a call with you. We will take your research question. We'll try to drive you to your outputs, whether it's a full HTA grade systematic review or whether you're trying to get a rapid answer by the end of the session. So thank you so much and looking forward to hearing from you.
Cool. Thanks, Kevin. See ya.